Okay, so here what we're going to do is we're going to consider how to graph this function, sine of omega times x. That's not a w that you see in front of x. It's actually a symbol called omega. And here we have omega is not 0. But it's really enough to assume that omega was positive, because if omega were negative, the negative sign you can actually pull out in front, because sine is odd. So you end up negating the whole function, but that's okay. So anyway, we're going to assume that omega is positive. Now, to actually graph this, what we're going to do is we have to figure out the period. Okay. Well, we know that if omega itself times x, we know as that ranges from 0 to 2 pi, sine of omega times x completes a cycle. In other words, when the entire input here, omega times x, ranges from 0 to 2 pi, then one cycle of this whole function is completed. But we want to know what happens with x, not omega times x, so we just divide. Dividing by omega, like so, okay? So the omegas here are going to cancel. The inequalities stay the way they are because omega is positive. We have 0 here, less than or equal to x, less than or equal to 2 pi over omega. So in other words, dividing as we did here, this tells us that as x ranges from 0 to 2 times pi divided by omega, sine of omega times x will complete one cycle. In other words, the period now of the function sine of omega times x, the period of this function now is 2 times pi divided by omega. 2 times pi divided by omega. And that also tells us one cycle is completed. Let's see if I can write this out. Is completed in the interval 0 to 2 times pi divided by omega. So essentially, if we want to graph sine of omega times x, if we want to see a full cycle of that, we have to plot this on the interval from 0 to 2 times pi divided by omega. And not only that, to get the important x values, what we're going to do is divide by 4. Let me just quickly write that down. So to obtain, maybe that's better, I guess important, putting it in parentheses here, also because they're all important, okay? To get the important x values, right? What we're going to do is we're going to divide the period, right, by 4. I mean, if you think about it, when we graphed sine of x, the period then was 2 pi, right? And to get the x values, we had pi over 2, pi, 3 pi over 2, and 2 pi. But we can get those by dividing by 4. And we keep on adding 2 pi over 4, which is pi over 2. So we divide by 4, and we're going to add. So when we graph, that's what we're going to end up doing. We're going to get the period, which tells us the interval on which one cycle is completed. And to get the important x values, we divide by 4. And we're going to add that quotient repeatedly. You'll see what I mean when we do an example now. So we're going to do this with sine of 2 times x. Okay, so just like before, let's get the period. So we have 2 times x, right? That's less than or equal to 2 pi. We have 0 less than or equal to this, right? Okay, so just like before, we want to get x in the middle, right? Okay, so let's do that. So again, let me just say it again, actually. Sine of your input, right? A cycle of that is completed as your input ranges from 0 to 2 pi. So in this case, our input is 2 times x. So I guess if you want, omega in this case is 2. You could think of it that way also if you want. But we want to know what x does, so we divide by x. So we're dividing everything by our 2. These cancel. 0 over 2 is 0. We have x in the middle. And on the right side, we have 2 pi over 2. 2's cancel. We get pi. So in this case, our interval we're going to work on, right? That's going to be the interval from 0 to pi. And not only that, our period as well is going to be pi. Okay, so now what we're going to do is start from 0. We're going to add pi. We're going to add pi over 4, the period over 4. Let's make a table to illustrate what's happening. So this is our x. Here we have y equals sine of 2 times x. So we start at 0. Here, what's the y value? Well, the y value is just sine of 2 times 0, which of course is sine of 0, which is 0. Next, we're going to add pi over 4, which is our period. So we're going to add pi over 4. So we're going to get, of course, just pi over 4. Now, what is sine of that? Well, sine of 2 times pi over 4, right? That's going to be sine of pi over 2. And that, as we know, is 1. So that's our y value here. Let me put y equals just to be consistent, as we can see. So again, what do we do next? We're going to add pi over 4. So pi over 4 plus pi over 4, pi over 2. Let me just move this up. So we have now y equals the sine of 2 times pi over 2, like so. So that, of course, is sine of pi, and we end up getting just 0. Next, we add pi over 4 again, and we're going to get 3 pi over 4, and now we do sine of that. So, excuse me, we plug that into our function, so we're going to have sine of 2 times 3 pi over 4, and that's going to be sine of 3 pi over 2, and that's going to be sine of 3 pi over 2, which, as we know, is negative 1. And finally, add pi over 4 again. Put a plus sign up there, and let me just make that look nicer. Here we go. And finally, we're going to have pi, the right endpoint of our interval, and we have y equals the sine of 2 times pi, which of course is sine of 2 pi, which of course is going to be 0. So that's what we do. We keep on adding pi over 4. So now we're going to graph our function. We're going to graph one cycle of sine of 2 times x. So again, we're going from 0. We're going to go, here's 1. And here's minus 1. Let me just make that look a little nicer. All right. Here's x. This is our y-axis. So again, we have pi over 4. We have pi over 2. We have 3 pi over 4. And here's pi. Okay, so to graph this, we know at pi over 4, we get 1. 0, of course, we get 0. Pi over 2, we get 0. 3 pi over 4, we get negative 1. And at pi, we get 0 again. So one cycle is going to look like this. Up to 1, down to pi over 0, down to negative 1, and back up to 0, as you can see. So that's what one cycle of this looks like. Now, if you were to graph this on the interval from 0 to 2 pi, you would have 2 cycles instead of 1. Okay, but again, how do we get those important x values? Basically, we're going to keep on adding pi over 4. Let's make a table to help illustrate this. But here, what I did was I drew this table. And so now if we want to know what happens after pi, essentially the pattern's going to repeat. So it's almost like pi over here, right, is going to take the place of this 0. And we add pi over 4. Okay, so let's do this. So adding, I'm not going to, pi over 4, right, we're going to get 5 pi over 4. Okay, now because of being periodic, at 5 pi over 4, we get the same as pi over 4, so we get 1, like so. And then, running out of room here, see if I can squeeze in one more. But next, if we were to add pi over 4, again, so bear with me, right? We keep on adding this. So next would be 6 pi over 4, which is actually the same as 3 pi over 2. So it's kind of hard to see this, like so. And next, after that, you would have 0, then 1. But again, the pattern repeats because it's pi periodic. You would have 0, right? Like so. Not to mention also, pi over 2, if you were to add pi to it, you would get 3 pi over 2. Hence, you would get 0 again. And the pattern would keep on repeating itself. Okay, so with that said, so now we're going to draw sine of 2 times x. But as you can see up here, what we're going to do is draw it on the interval from 0 to 2 pi. Okay, so let's do that. So here's 0, 1, negative 1. So we have pi over 4. Then we have pi over 2. 3 pi over 4. Then we have pi. So again, we keep on adding pi over 4. So after pi, we get 5 pi. Well, wrong color. We get 5 pi over 4. Then we get 6 pi over 4. But that's the same as 3 pi over 2. Then we get 7 pi over 4. Then we get 8 pi over 4, which is 2 pi. Now we're ready to draw sine of 2 times x. So at 0, we have 0. As we saw earlier, pi over 4, we get 1. Pi over 2, it comes down to 0. 3 pi over 4, we get negative 1. Pi, we get 0, like so. Then at pi over 4, that's the same as at pi over 4, because we're adding pi. 3 pi over 2, you come down to 0, right? 1, 0. Then at 7 pi over 4, we get negative 1. At 2 pi, we're back at 0. Okay? So again, the pattern repeats. So we have 1, 0, negative 1, 0. That's one cycle. So we're going to draw another cycle. Up to 1, 0, negative 1, back up. So we get 2 full cycles in this interval, which again is expected because the period is pi. But again, let me just point out again. At pi over 4, we got 1, right? If you were to add pi, right, which is 4 pi over 4, so you're moving to the right 4 steps, so to say, you're going to be at 5 pi over 4, which is why we get 1 again. Pi over 2, same idea. You're going to add pi. and adding pi, you're going to be at 3 pi over 2, and that's why you get 0 again, and so on. So in other words, you can use the fact that it's pi periodic to graph the sine function.